Okay, good. Okay, now, so first of all, if you have a question like this, try to multiply with the conjugate at the bottom and then change it to I plus x plus iy, okay, to the real and imaginary form x and iy. So in this case, 1 minus 2i, I have to times it by 1 plus 2i. Okay, do the same thing. Okay, 1 plus 2i, and multiplying conjugate that at the bottom we will rationalize the complex number equation, and from there, or the function, and then from there you will get in form of x plus iy. So let's expand this. So I did that earlier. So 2 plus 4i plus 3i plus 6i square over, and this will be 1 minus 4i square. So what you have here is 2 plus that's 7i minus 6, okay, over 1 minus an I square, okay, is -1. I think you guys know that. So -1 plus 4, -1 times by -4, which is +4. And when you simplify that, you get -4 plus 7i over 5, which I can break it further, okay, to -4 over 5 plus 7 over 5i. So z equals to -4 over 5 plus 7 over 5i. Okay, can you guys see this? Yeah?
Yeah.
Hello?
Yeah, sorry.
Okay, so now we are not done yet. Okay, we still have to find what is r. Okay, 5 marks. Okay, and then the argument as well. So let's do that. So but this is the first step. Once you got to this stage, okay, you are comfortable to do the rest. Okay, so r modulus is just x square plus y square. So in this case, you have -4 over 5. Okay, square that, and then plus 7 over 5, square that. So I did this just now using calculator. What I got was 65 over 25. Okay, so 65 over 25. If you use your calculator, you'll be getting 1.6125. Okay, so that's the length or the unit of for the function z equals to -4 over 5 plus 7 over 5i. Okay, so I've got that. Next, I have to find the argument. Okay, argument of z, which is, in this case, to find the argument of z, okay, every time whenever the question requires you to find the argument of z, okay, split that into coordinates and then try to sketch them. So we have -4 over 5, which represent the x-axis or the real axis, and then 7 over 5, which represents the imaginary axis. Okay, 7 over 5i. So let's draw this. Okay, so, or at least sketch. So we have -4 over 5 is actually 0.8. It's not even 1. Okay, so if -1 is somewhere here, okay, somewhere here, so -4 over 5, which is -0.8, will be somewhere here. Okay, just approx. And 7 over 5 is 1 point something. Okay, I think it's 1.24. Yeah, 1.4. Okay, it's 1.4. So this is your IM, imaginary line, and that's your RE. So 1.4 approximately, maybe somewhere here. Okay, it doesn't have to be accurate. Okay, just approx, just to give you some idea. Okay, where it is. Now this is the argument that I'm looking for. Okay, straight line. Okay, so this is the argument that I'm looking for. Okay, which is theta. Are you guys okay so far?
Yeah.
Yeah?
Yeah.
That's the angle that you're looking for. But we know it's pi. Okay, the radian is pi, 180 degrees. So you have to find what is the alpha over here. If I know the alpha, all I have to do is just pi minus the alpha will give you theta. Pi minus the alpha will give you theta. So let's find out what's the alpha. So to find the alpha, so we know that is your y-axis, okay, and this distance is x-axis. So let's find theta. So theta equals to pi minus arctangent of 7, no, y over x, right? Yeah, 7 over 5 divided by 4 over 5. Okay? Okay, yeah, 7 over 5 minus 4 over 5, which gave me, okay, just looking at this one here, okay, the arctangent or the inverse tangent, which is 1.4 divided by 0.8. 1 pi minus 1.0517. Okay, 0517 RAD. So from there, we got the theta as 2.0899, which approximately to 3SF is 2.09 RAD. Okay, so therefore, rewriting in exponential form, R e to the power of I theta is, no, don't write in terms of cert, I'll just write it in terms of the R, which is 1.6125, okay? And if you want to write it in terms of cert, which is cert 65 over 5, also can, nothing wrong, okay? And e to the power of 2.09 I, okay? 2.09 I. Okay, I guess okay with this, 5 marks for that.
Yeah.
Yeah.
Okay. Okay, next, on Argand diagram, sketch the locus of points representing complex number z satisfying the equation z minus 3 plus 2i equals to 1. Okay, z minus 3 plus 2i equals to 1. So you have to split that, find out what is the coordinate. Okay, it's not in, you need to change it to z minus zi in that form, remember. Okay, so from there only we can find out. And then once you're done that, then we can find where's the coordinate. So we'll do that. And then find the least value of z or the locus, okay, for the point on this locus. Okay, meaning what is the nearest, okay, to the locus. So first of all, we should know, okay, let's do this. Okay, part B. Okay, for part B, first of all, let's write down the coordinate, okay, or the function first, z minus, the equation is z minus 3 plus 2i modulus equals to 1. Okay, z minus 3 plus 2i. Okay, I got that, equals to 1. So from here, you split that into z, okay, minus 3 plus 2i equals to 1. So if you split that, okay, remember it has to be in this form, z minus zi. Okay, so z minus z. So now this is in z minus zi, whereby what are the coordinates that you have? You have your real value as 3, and then your imaginary value as sorry, this should be, that's plus, so that's minus, isn't it, guys?
Yeah.
Yeah.
Okay, if I make a mistake, please let me know. Okay, don't just be quiet. Okay, so because it has to be minus and then plus, so it has to be 3 and negative 1, so negative 2i. Okay, so once you have that, then from there we know the coordinate is 3 and minus 2i. And what is the radius? Radius
1.
is, yeah, okay. Okay, so quite simple. I mean, it's not really a challenging question if you know how to do this. Okay, first let's plot the points. Okay, that's your IM, imaginary axis, and that's your RE, the real axis. So 3 and minus 2, 3 positive, 1, 2, 3. Okay, okay, just approximately. And then negative 2i, so negative goes to the negative axis, so that's minus 1, and then let's say that's minus 2i. Okay, just approximately, okay, it doesn't have to be accurate. So, and then this is your center, the coordinate, and what is the radius? It's 1, so I'm going 1 up, 1 to the right, then one to the left, and then one down south. Okay, now let's join. Okay, now let's join. You get a circle, somewhat like that. Okay, you get a circle. Ah, sorry. Okay. I like to draw a circle as a proper circle. Okay, otherwise it looks so deformed. Okay, now that looks like a circle. Okay, now, okay, what's the question? The question requires us find the least value of modulus z for the points on this locus. So this is your locus z. Okay, we got that. So where is the least point? What is the shortest distance? Meaning, what is the least point from your origin? So it's somewhere here to the center. So this is your least point that they are looking at. This is your least point. Okay, or the distance. Okay, this is what I want to know. What is the least value, okay, of the modulus here? So this is what you have to find. Okay, least, find the least value of z. Okay, least value of z. Okay, can you guess? Are you following, guys?
Yeah.
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 Okay, so to find that, I need to know what is the distance. I know this is 1 because radius is 1 and that's 1. And if that's 1, this is also 1 because, okay, the coordinate, we already got that. Okay, so this is another 1. So altogether, okay, from here to here, it's positive 2. Okay, so that's 2. Okay, the distance is 2. Now, this is 3. So can I find the let's say I'll just make it as x. Can I find this distance?
Yeah.
Yeah, okay.
Yes.
So we can use Pythagoras. Okay, so this is 2, this is 3. So from there we get 3 squared plus 2 squared, which is 9 plus 4. Square root of 9 plus 4, which is 13. Okay, I'll just leave it as 13. Okay, so to find the question here, find the least value of z for points on this locus. Okay, for points on this locus. So least value of z is they are looking at this value. They don't want what is the coordinate. They are not looking for the coordinate. They want what is the least value of z. So the least value of z is, which is this part here, the blue in color, least value. So how do I find that? If the whole thing is square root of 13, therefore the least, okay, value of modulus z to the locus is surt 13
Minus 1.
Very good. Okay. That's it. Okay, so you get 9 marks. Okay, this is 2018 winter paper. Okay, quite a not really a challenging paper. Okay, you could do this. Okay, so I'll do one more. What do you think? You have time?
Yeah.
Yes. Okay, we'll do one more. I'll add one more page.